All right, lesson 5.4 for sum of difference identities for a sine and tangent function today for our trig class. On the pink formula sheet, again, it'll be on those top rules on the above that first bar. So make sure you have your pink sheet out today while we're doing these notes. It'll be helpful. All right, first one is find the exact value of the expression for sine of negative 15 degrees. Negative 15 degrees is going to put me down into quadrant 4, actually. So I'll kind of show you a little picture of that. Negative 15 degrees. So when I'm looking down here at negative 15 degrees for the sine function, I know that'd be equivalent to the sine of 15 degrees, but it would be negative sine of 15 degrees. Because from all students take calculus, the sine there would be a negative value. So that would be equivalent to the negative sine of 15 degrees. Now I could have written it that way. I could also write it as a sine of 30 minus 45. So there's a couple different routes that you can do with this. You could have also done 45 minus 60 would also work as well. And these different answers will be correct on the test and in the homework system both. So at this point, I'm going to look on the right-hand side on the pink sheet, the second formula down. So I'm going to pull this out. All right, pink sheet, second formula on the right. So we've got the sine of A minus B, and that's going to equal the sine of A cosine B, and then minus cosine A sine B. Everywhere there's an A, you need to plug in 30. Everywhere there's a B, you will plug in the 45. And again, like I said, please have the formula sheet out. If you're at home and you don't have a formula sheet, please log out of the video, go back to your college Canvas, and print the formula sheet. I have that loaded on the college Canvas page, and then come back and continue your notes. All right, now for 30 and 45 degrees, at 30 degrees, we do know that the cosine would be a radical 3 over 2. The sine of 30 would be 1/2. The sine and cosine at 45 both are 1 over radical 2, but we don't normally leave the radical on the bottom. So that was just plugging in from our sine and cosine for 30 and 45 degree angles. Now this first numerator is going to be radical 2. The denominator is 4. This one's going to be minus a radical 6 over 4. Again, the denominators are already the same, so therefore I can go ahead and combine my fractions to radical 2 minus radical 6, the quantity of that, divided by 4. So the tangent of 13 pi 12s, just like when we did the cosine sum and difference rules, we switched those to degrees. Please do the same here. So I would do 13 times 180 divided by 12. That's going to give me 195 degrees. 195 degrees is going to put me into quadrant, hopefully you guys are thinking quadrant 3, with a reference angle of, all right, so I want you to think about that for a second. So you're at 195 degrees, so that's going to put you into quadrant 3. Okay, so here's my little picture from 195 degrees. And remember, reference angles, how far off of the x-axis? So how far off of the x-axis is that? That's 15 degrees off. And it goes, all students take calculus, so the tangent there would be positive. So this actually is equivalent to the tangent of 15 degrees. Now 15 using only 30, 60s, and 45s, because those are the values that we know right off without a calculator. Again, we have no calculator on this. We just got to know the values off the top of our head. So I'm going to have my A and my B for my tangent rule are going to be 45 and 30. Again, I'm going to be on the right-hand side because that is a subtraction. On the pink sheet, the bottom one on the right. We're only looking at these top formulas right now at this point. So the tangent of A minus B is going to be tangent of A minus tangent of B, and then that's over 1 plus tangent of A times the tangent of B. And again, everywhere there's an A, plug in 45. Everywhere there's a B, plug in the 30, please. So I've done that. Tangent of 45 is 1. Tangent at 45 degrees, 1 over 1. Tangent at 30 degrees, 1 over radical 3. So I did my plugging in. Now I cannot have these fractions within fractions. So I should multiply this entire numerator by radical 3, and you should multiply the entire denominator by radical 3 as well. So when you do that, and you're taking square root of 3 times this 1 here, that's where I get the square root of 3. Square root of 3 times this fraction, that's where I got the 1. Square root of 3 times 1. And then square root of 3 times this fraction would give me just 1. Now, a lot of people like to say, oh, there's my answer and I'm done. That'll get you partial credit on the test, but you're not finished. And if it's multiple choice, that won't even be an answer. We need to simplify it. We cannot leave the square root in the bottom. So I'm back to college algebra and algebra 2. You weren't allowed to leave the square root in the denominator. And this is when we multiplied by the conjugate. The conjugate will be the radical 3 minus the minus 1. So I'm going to change just the sign right here. We're going to FOIL or box the top, either FOIL or box the bottom. The denominator becomes 2. The numerator is now 4 minus 2 radical 3. Now this reduces. 2 goes into 4 2, and 2 goes into 2 once. And there's our final answer. Now, C, you'll notice, is another one of those kind of like it's going backwards. See, because I don't know the tangent of 70. I don't know the tangent of 100. To get 70, we're using only 30, 45, and 60. I really can't get 70 out of that, even if I try to throw in a 90 or a 180, because I know those as well. Same thing for 100. I can't get 100 using 30, 60, 45, 90, you know, some sort of sum or difference. So if I'm taking a look at the tangent rules, notice that numerator has a minus sign. So I need to look for the tangent rule that has the minus sign right here in the numerator as well. And notice it was this one, the right-hand side. Tangent A minus tangent B over 1 plus the product of those. And therefore that it's going to be tangent of A minus B. So I'm going to plug in A as 100, B as 70. So this is equivalent to the tangent of 30 degrees. Now the tangent of 30 degrees, you go back over here to your 30-60 triangle. The tangent of 30 degrees opposite over adjacent leg, 1 over radical 3. Don't leave the radical in the bottom though. Write each function as expression involving the functions of just theta. So in other words, we don't want a theta and a 270 or a theta and a 3 pi or a 120. So they're telling me, they're making me use these sum and difference rules. In the first one for problem A, my A is theta, my B is 270. So we plug into our pink sheet. That'll be the rule on the right-hand side, the second one down. Now, 270 degrees, y'all, that's going to be 90 degrees, 180. 270 is going to put me at the bottom on the circle using the point 0, negative 1 with the radius of 1. Remember that the cosine is the x over r, so 0 over 1 would be the 0. The sine at 270, that would be the y over r, so negative 1 over 1, which is negative 1. 0 times anything would be 0, so this is 0. That's just gone. Negative times negative is positive, so we get positive cosine of theta for the answer. All right, tangent of theta plus 3 pi. So again, we're going to plug into our rule. 3 pi. Let's talk about where we get 3 pi from. If I start here at 0 radians, go around, there's 1 pi, 2 pi, 3 pi. So I'm going to stop right there and use the point negative 1, 0. So one more time, how did I get 3 pi? So I'll use the red pen. Maybe I'll sound a little better. All right, starting at 0 radians, we go around, 1 pi radian, 2 pi radians, 3 pi radians. So that's why I'm using the point negative 1, 0. Now the tangent was y over x. Y over x happens to be 0. So the tangent of 3 pi is 0. So right here I get tangent of theta plus 0. That's just tangent theta. On the denominator, this tangent theta times 0 would be 0. And 1 minus 0 would still be 1. So that's how I get the final answer of tangent of theta. Again, the denominator is just 1. The numerator is tangent theta plus 0, so just tangent theta. All right, sine of 120 degrees plus theta. So this time on the pink sheet, which formula? Take a look for a second. They're adding, and it's sine, so it should be the second one on the left-hand side. You're going to plug in everywhere there's an A of 120 and everywhere there's a B of theta. Now this time this is a little bit trickier. See, 120 degrees is going to fall in quadrant. Hopefully most of you are thinking quadrant 2 with a reference of 60 degrees. So I'm going to show you the sine of 120 again. So the sine of 120, we are going to start with 0 degrees. This would be 90 degrees. We go around, we stop here, because if I kept going to this x-axis, that would be 180 degrees. So this is the angle, 120 degrees. Now that gives me a reference angle of 60 degrees. I hope that's what most of you were thinking. Now by the statement, all students take calculus, the only one that's going to be positive here is going to be the sine, will be positive. So I could rewrite this. When I'm looking for the sine of 120 or the cosine of 120, I can rewrite them in terms of sine or cosine of the reference angle of 60 degrees. And then by using my all students take calculus, I know the only one that's going to be positive will be the sine. The cosine and the tangent would be negative there. So now back to the problem for a second. So the sine of 120 is going to be equal to the sine of 60 degrees. The cosine of 120 is going to be negative because the cosine in quadrant 2 is negative, and then the cosine of 60 degrees. Now we need our 30-60 triangle. The cosine at 60 degrees is going to be 1/2, and the sine at 60 degrees will be radical 3/2. We now plug those values in. And that's our final answer. See, we have all of these trig functions with a single theta, because it's right in my directions. Write each function as an expression involving functions of theta, meaning they didn't want anything else with the theta. We do not have anything else with the theta. It's just cosine theta, it's just sine theta. So again, this is a little bit tricky. It's just figuring out what the directions want and then being able to do that. Suppose that angles A and B are in standard position, where cosine of angle A is negative 7/25, and angle A is between pi and 3π radians. Pi would be the left side of the x-axis. 3π would be going down on the y-axis. So that's going to put me in quadrant 3. That's between 180 and 270 degrees for angle A. Angle B, the sine of angle B is negative 3/5. I'm told angle B is between 3π and 2π. So it's very important for us to remember our radian measures. So I'm coming back to this for a second. Remember, this would be 0 radians. This one up top is π². To the side is pi. To the bottom is 3π². And then back over here is 2π from 0. So again, you want 0 to π², π² to pi, π² to pi to 3π², 3π² to 2π. So we need to understand where those are at. It will help you if you have those memorized. So we are looking for angle A to be in quadrant 3, angle B to be in quadrant 4. In quadrant 3 for angle A, my x is negative, my y is negative, and my r is positive. For angle B, which ended up way over here into quadrant 4, that one I only have the y as negative. X is positive this time. Going back to what I was given, I am given the cosine. So cosine is x over r. So for angle A, I know x and I know r. I know it's 7 and 25. To get this answer of 24, I do my Pythagorean theorem. Remember, x squared plus y squared equals r squared. So you would do 7 squared plus y squared equals 25 squared. Once you take your 25 squared and take away the 49 from 7 squared, you get that answer, and then take the square root of it. All right, the sine of angle B is negative 3/5. The sine is the y value over the r, so negative 3/5. Again, if you do Pythagorean theorem, so x squared plus y squared is r squared. Well, some of you also know the Pythagorean triples, 3, 4, 5. As long as 5 is the hypotenuse, that would be the Pythagorean triple anyways. If the 5 here had happened to have been a leg, let's say a leg of 5, a leg of 3, then the hypotenuse would not have been 4. So just make sure you understand that if you do have a 3, 4, 5 ratio that you think you have, make sure the 5 was for the hypotenuse before you assume the missing side is 4. All right, now back to your pink sheets. Look up for the sine of A minus B. Okay, that's the second column, or the column on the right, and the second equation. So we're going to fill that in. Now, the sine of angle A, so I go to angle A, the sine is the y over the r, so negative 24/25. All right, then it says the cosine of angle B. So we go to angle B, the cosine would be x over r, so 4/5. The next part was the cosine of angle A. So the cosine of angle A, you go to angle A, the cosine is the x over r, so negative 7/25. Then it said the sine of angle B. The sine of angle B, you go to angle B, the sine is the y over the r, and that's your negative 3/5 there. We go ahead and take care of multiplying our numerators, multiplying our denominators. Notice we have a common denominator of 125. So therefore we can just go ahead and combine our numerators. Negative 96 minus 21 is negative 117, denominator of 125. All right, tangent of A minus B. So A minus B, tangent, you're going to go to the top on the right-hand side, third formula down on the pink sheet, and you're going to plug in. Now, the tangent of angle A, so I go to angle A, the tangent is y over x, negative 24/25. The tangent of angle B would be y over x also, but negative 3/5. So we plug in all our values. I'm sorry. Oh, I meant to say y over x, and I think I just used the r. I don't know if I did on both of them. Sorry about that. So tangent of angle A is going to be y over x, negative 24 over negative 7, so positive 24/7. The tangent of angle B is y over x, negative 3 over 4, so negative 3/4. Once we fill those in, I do have a common denominator of 28 that I like to go ahead and take care of some stuff here. See, if I multiply both of these fractions by 28, I multiply 1 times 28, and then I multiply that, and that's where the 28 is coming from. If I take these two fractions right here times 28, that 7 times 4 on the bottom is a 28. Well, if I multiply it by 28, I will no longer have a fraction there. So again, 24 over 7 times 28. Well, how many times does 7 go into 28? That goes 4. So then I just need 4 times 24. That's where the 96 comes from. Then this minus and that negative becomes positive. 4 into 28, 7 times 3, there's the 21. The next one, we had 28 times 1, so that's just 28. On the next one, notice this 28 would actually reduce with this denominator of 28 here, so I need negative 3 times 24. Now we simplify our numerator, simplify our denominator, and then you should always check if the fraction reduces. This one did not reduce, so it was done. Now the interesting one on this one, see, we know angle A was in quadrant 3, and we know angle B was in quadrant 4, but to finish up the question, they want to know in what quadrant would A minus B fall. See, right here, guys, we know the sine of A minus B is a negative value. The tangent of A minus B is also negative. So by your all students take calculus, you'd want to figure out where is the sine and the tangent both negative. So if you had done your all students take calculus, again, that one's telling me that the sine is negative. So sine is only negative in quadrant 3 or 4. The tangent is only negative in quadrant 2 or 4. So that only repeated for 4. So that final answer was quadrant 4. All right, verify this identity. On the left-hand side, we're going to start with the tangent of pi fourths plus t. So we're going to go ahead and we're going to plug in. The next one was plus the tangent of pi fourths minus t. Now we're going to, pi fourths would be equivalent to 45 degrees. The tangent at 45 degrees happens to be 1. So that made that one kind of nice because all the tangent of pi fourths became 1. Now we're supposed to simplify this because if you notice this right-hand side is a single fraction. I don't want two separate fractions. I need to make that into a single fraction. So to do that, we have to get a common denominator. The left one needs to get multiplied by a 1 plus the tangent of t on the top and the bottom. And the one on the right needs to get multiplied by a 1 minus tangent of t on top and bottom. Because I need that denominator over here, and I need this denominator on that one. So again, both of them got multiplied by that. You will FOIL out, box out, or some of you can square those. 1 squared, multiply the 2, that's 1 tangent t doubled to 2 tangent t. Last one squared is tangent squared. First one squared is 1, multiply the 2, doubled, negative 2 tangent t. Last one squared. There's the denominator. Notice we already have the denominator of what this answer set up here. That was kind of nice. In the numerator, I want you to notice we do have the negative 2 tangent t's will go away. They cancel, they reduce, they simplify to 0. But I've got 1 plus 1 is 2. So we have a 1 here and a 1 here. That's the 2. You have a tangent squared plus a tangent squared, and that's the 2 tangent squared. Now, out of the numerator, I can factor a 2 out. So I factor a 2 out of both of those. Anytime you guys see 1s and trig functions squared, please be thinking about those Pythagorean identities. We are back to those again. So 1 plus the tangent is squared. Here is 1 plus tangent squared. That is secant squared. So 1 plus tangent squared, that's secant squared. We have actually finally finished that off. Now you'll notice most of those, I think you've noticed they were multiple choice. It's a matter of eliminating step by step which ones are not following. Like from here to here is the step true or false is what you're looking for on those multiple choice. As soon as you're seeing them false, start crossing those letters off. So please try to do the multiples of 4 before coming to class for lesson 5. I appreciate it greatly. You'll have a great day.